So we're going to use inductive reasoning, which means we're going to look at a pattern, and then assuming that pattern continues, we're going to find the next pieces in the sequence. And in some cases, it's lists of numbers or letters. Sometimes you're going to be writing rules. But when I look at this first one, I'm sitting there saying, well, 26 plus 28, I'm adding 2. 28 to 32, I'm adding 4. 32 to 40, I'm adding 8. Then I'm adding 16. Next one I'm adding 32, and I said 16 and I wrote 6. So the thing that I'm adding is doubling every time, which means I'm going to add 64 the next time. Well, 88 plus 64 is 152 if I just did that right in my head. And then after I add the 64, I'm going to add 128. Again, keeping that pattern going each time. 152 plus 128 is 280. Now the second one, I went ahead and had typed up this review sheet, knowing what I had in my head as the pattern for the next one. And then Ms. Bader did her own answer key, and we compared answers to make sure that hopefully neither one of us made a mistake. And she found a different pattern in here than I had intended, but a perfectly acceptable pattern. So there are two possible answers for this one. The letters are pretty straightforward. If I go from M to K, I'm going back 2 letters in the alphabet. And if you're like me, I need to have some of that written out. So G, H, I, J, K, L, M. I went from M to K, so I went back 2 letters. And then from K to I, going back 2 letters again. So from I to G would be back 2 letters again. And I'm alternating letters with numbers here. So after this number, I would have to have G as my next letter. What I had intended to be the case on the numbers was sort of a takeoff of the Fibonacci sequence, where you add the 2 numbers to get the next one. So -2 and -3 is -5. -3 plus -5 is -8. So what I did was -5 plus -8 to get -13 in this block. Now what Ms. Bader did was she was saying, well, from -2 to -3, I'm going down by 1. From -3 to -5, I'm going down 2. -5 to -8, I'm going down 3. So she went down 4 for her next one, and she had an answer here of -12. So it's good to actually show me how you're getting this, because that's a perfectly reasonable answer. But if I just saw a -12 there, I'd be thinking it was wrong. So how did you get? I mean, show this work. How did you get to the next thing? How did you get to the next thing here? If you show that work, it's understandable, and it's possible that sometimes there's more than one correct answer. In this case, gives me this table. It wants me to find the nth term of the sequence. Well, I'm looking for that pattern again, and I'm noticing from 20 to -3, I'm going down 23, going down 23 again, down 23 again. So I end up actually having a constant difference, which means this is linear. So the nth term means I want to actually give not an equation for this, but an expression where I could give you any term number, you pop it into the expression, and you can tell me what the value of that term number is. Well, this is like the slope of my line. So remember, slope is the coefficient of x, or in this case, the slope is the coefficient of n, because instead of using x, we're using n. The problem is, if I take -23 times 1, I don't get -23. -23 times 2, I don't get positive 20. -23 times 2, I don't get -3. So there's got to be some way to adjust for that. That's like going back and finding the 0 term, which would be like the y-intercept. These are sort of my x values if I graph these. These are my y values. Well, 2 ways to do that, and again, showing me work is good. If I'm decreasing by 23 every time I'm moving to the right, then I would be increasing by 23 when I go backwards. 20 plus 23 is 43. I could also sit there and say, well, I know that if I take -23 times 1 and add whatever constant I'm looking for there, it's got to give me the answer of positive 20. So I can solve this By adding 23 to both sides, C is 43. So there are at least two good ways to get that and show work so that if you're wrong, you have a chance of getting more partial credit. So my nth term is actually negative 23 times n plus 43. So I've got that negative 23n plus 43, and it wants me to find the 150th term. The reason we wrote this expression is so we don't have to list out the 149 terms before that to get to the 150th. I'm going to take negative 23 times the 150 and add 43 to that. Well, when I plug this in my calculator, negative 23 times 150 plus 43, and yes, you should show me the work, I get negative 3,407. So if I listed all those terms out and I calculated it correctly, I'd get negative 3,407 for that. So that's what you're going to be asked to do on Learning Target 2.3. Thank you.